Okay, we're going to be looking at prime factors in this video. Basically, a question may ask you, write this number as a product of its prime factors. Remember that a prime factor is a number that can divide another number, such as this one, but it'll also be a prime number. A prime number is a number that can only be divided by itself and 1. So you should have a list of your prime factors in your book, all the way up to 50. If you don't, I will put the list on Moodle for you to find, and you can have a go of these. A prime factor tree will break down any number into its prime factors. Doesn't matter which way you divide, if you get to the each branch has its prime factor at the end, you'll end up with the same answer as somebody else has worked out a different way. So if I have a look at this number here, I'm going to draw 2 branches from this number. These 2 numbers here, when times together, will end up making 78. So, looking straight at 78, I know that that is an even number. So I am going to put 2 there. I would then have to write the number. If I did 2 times something, it must be 78. 2 times 39 is 78. Now this number here isn't prime. This one is. When you get to a prime number, that's the end of your branch, okay? I always circle them so it reminds me that it's a prime number, prime factor. I can't go any further with that one. With this one, however, I can create another 2 branches. I could say that 3 goes into this number. If I divide that number by 3, I would end up with 13. Both of these numbers are prime. So I will circle both of them. The final step, showing it as a product, just means you have to do this. Multiply them all together. This is in fact your answer right now. Now the examiners like to get your numbers in ascending order, so you should always start with your 2 and then go up to your highest. If you end up with more than one of the numbers, say if you had 2 and 2, you would write 2 to the power 2 rather than writing 2 times 2. I'll show you an example of that in the next couple of seconds. So we've just got another example here, which is 100. We're going to look at taking out the prime factors, and what I might do just across here is show you that you will end up with the same answer even if you divide by different numbers. So for this first one here, let's divide this one by 2. If I divide that one by 2, I would end up with 50. With this one, I'm going to divide by 20. And that will leave me with 5, which is a prime factor as well. Going back to this one, a number that goes into 50, I could have 25. And again, I would be left with 2, which is a prime factor. If I have a look at this one, I could go 4 and 5. Again, circling my prime factors each time, so I know that's the end of the branch. 25 can be made with 5 and 5. They're both prime factors, and now I've completely finished. I can't go any further. This tree won't get any bigger. With this one, 2 and 2 makes 4. Now note that I'm never using 1 here, because 1 isn't actually a prime factor. 1 can only be divided by one number, which is 1. So you would always use 2 as your lowest number to use. So well, if you did divide by 1, you wouldn't actually end up with a different number coming down here. You'd have the same number and the same problem to deal with the next time. So if I look at my prime factors here, I've got 2 squared times 5 squared, and I've got 2 squared times 5 squared, which just proves that no matter which way you divide, as long as you're doing it right, you'll end up with exactly the same answer. 2 squared times 5 squared is 100. Okay, so you might be thinking, what can I use prime factors for, other than finding the product of its prime factors? Well, very simply, you can find the highest common factor of two numbers. If I gave you 25 and let's say 40, you might know it straight away, but just so you understand the method, let's go through this in the way that you should do. First of all, doing the prime factor trees is key. 5 times 5 makes 25. So 5 squared there, that's the product of its prime factors. This one, we would have 8 and 5, 2 and 4, 2 and 2. These are all prime factors. So for this one, I've got 2 cubed times 5. Now, all you have to do to find the highest common factor is look at what's common in both sums. Right underneath that one that it is 5 times 5. The common thing in both those sums is a 5. All you have to notice is that that is the common one. That's your answer. If you had two numbers that were common, so if you had 2 times 5 times 5, which is 50 instead, you would pull out the 2 and a 5, so you'd have 10. Let's look at one of those examples now. Okay, so another example. We're still looking for the highest common factor. Might not be as obvious this time, but without having to go through all the factors of each number, we are just going to work it out using prime factors. So 27, I can make that using 9 and 3. 3 is my prime. To make 9 is 3 and 3. They're both prime numbers as well. And that's the end of my branches. So 3 times 3 times 3 makes 27. Otherwise known as 3 cubed. 81. Let's say 9 and 9. And then I'll feature these branches because neither of those are prime numbers. 3, 3, 3, oh, 3. So 3 times 3 times 3 times 3 is 81, 3 to the power 4. So look at what's common. We've got 1 3 in both, 2 3s and 3 3s. So my highest common factor is 3 times 3 times 3, which is 27. The highest common factor of 27 and 81, a number that goes into both 27 and 81, is 27. Okay, so this time we're going to be looking at the lowest common multiple. Note that this time, rather than being highest, it's the lowest. We don't want the highest one, that could go on forever. It's got to be common, and it's a multiple being, if it was a table of 4, it would be 4, 8, 12, 16, and so on and so on. Okay, so those are multiples of 4. Basically, you're looking at a number that is in the times tables of each numbers you're looking at. So let's have a look at 25 and 40 again, because we use those for our highest common factors. 5 and 5 makes my 25. 8 and 5, which is 2, 2 and 2. So here's my sum. 5 times 5 is 25. 2 times 2 times 2 times 5. For this, what you have to do is you pick out the biggest groups. So my prime factors are 2, 3, 5, 7, 11, 13, 17, 19, and it goes so on, so on, and so on until, you know, constantly going. But you only need to know up to 50. Because I don't have these numbers in both of these sums, I'm just going to stick with these ones for now. So the largest group of 2s I've got no 2s in there, but I do have 3 2s in here. So I pull out the 3 2s. My lowest common multiple is going to be 2 times 2 times 2. Then I move on to the next number, 3s. I don't have any 3s at all, so I move on. 5s. My largest group of 5s is this one. So I ignore this one, leave it where it is, and just take these ones. And after that, I don't have any more of these prime factors. All that's left for me to do is to work this out, which is 8 times 25, which is 200. The lowest common multiple of 25 and 40 is 200. So again, looking at the lowest common multiple of these two numbers, firstly break them down into their prime factor trees. So we've got 3 and 4, 2 and 2, 4 and 4, 2, 2, 2, 2. So the sum for this one is 2 times 2 times 3. The sum for this one is 2 times 2 times 2 times 2. These are all my prime factors. The next step for me to do is to work through picking out the largest group of each prime factor, starting with my lowest, which is 2. Which one has the largest group of 2s? Have a look. Yeah, that's right, it's this ones here. There's 4 of them, and I take all of those and ignore the ones there. The next step, have a look which one has the largest group of 3s. Well, this one doesn't have any, so we're just left with that one there. So we've got 2 times 2 times 2 times 2 times 3, which gives you 48. If you were to go through the times tables of both these numbers, 12 and 16, the lowest common multiple, a multiple that occurs in both times tables, the answer would be 48.